Welcome and a very good day to everyone. Today we are going to talk about the effect of ion concentration on electroplating of copper. First of all, I would like to share a key insight from this experiment. Although electroplating appears simple, I realized how significantly the concentration of copper ions affects the deposition process. By applying Faraday's laws, we examine how varying copper to nitrate concentrations influence the mass of copper deposited with constant current and time. This experiment not only reinforced theoretical concepts but also highlighted the real-world relevance of electroplating in industries such as electronics and metal finishing. First of all, I would like to share a key insight from this experiment. Although electroplating appears simple, I realized the objective of our experiment is to study the effect of concentration of copper to nitrate to the mass of copper deposited on cathode for electroplating process. The objective of our experiment is to study the effect.
For methodology part, the chemical used are copper nitrate trihydride solution and also the distilled water. For the copper nitrate trihydride solution, there will be 5 concentration will be prepared: 0.05 m, 0.1 m, 0.2 m, 0.5 m, and also 1.00 m. And the distilled water will be used to dilute the solution. Then the apparatus used will including the beaker, volumetric flask, and the copper strip will act as the electrode, and the sandpaper will be used for clean the copper strip. The apparatus including analytical balance used for the weighing process, DC power used to supply the current for the cell, then the multimeter show the current reading of the cell running in the experiment, and also the wires with the crocodile clips to connect the circuit. At first, weigh 60.405 grams of the copper nitrate trihydride salt, then dissolve it in the distilled water to prepare 250 ml of 1.00 n copper nitrate trihydride solution. The prepared solution used to prepare another 4 concentration of the solution. At first, weigh 60.40. At the same time, the copper strips are cleaned with the same paper and weigh it as the initial mass. The apparatus will set up like the picture shown. At the same time, then voltage be supplied for 1.58 current, which is the control variable in the experiment for running the cell. And the 0.05 m copper nitrate trihydride solution will be used first, and the experiment only run for 5 minutes. Then the cathode will be taken out for drying and weighing process. Whole experiment was repeated using other 4 concentration solution.
Hi, my name is Ainul, and today I would like to present about this result and data we collected from our experiment. Hi, my name is. This first table show our variable factor, which is concentration of the copper nitrate trihydrate, while our control variable is time, temperature of the solution, and applied current. What we measure during the experiment is the mass of the copper strip before and after the electroplating process. This second table shows the data that we obtained from the calculation. This slide show all of the formula that we use to get our data from the second table, and we can see here that we use Faraday's law to calculate our maximum theoretical mass of the copper deposited. Next, this is our linear graph with the r squared equal to 0.934 for all 3 of them.
So for the discussion part, the half cell reaction has represented with the equation below. From the first picture, we can know the electron is flow from the terminal negative to the cathode. Then the copper ion attract to the cathode will be discharged instead of proton molecule. Since the copper more electropositive standard reduction potential, the electron flow in the surrounding of the electrolytes. The copper at anode will oxidize itself to give the copper ion in the solution. Then the electron flow to the positive terminal. And for the second picture is about the comparison of the higher and the lower concentration. And obviously, the higher concentration will have more ions. And this explains why the higher concentration will have higher deposition rate and the mass. Since there are more ions can carry the charge and more ions can be discharged at the cut. So after the experiment had done, we observed that the anode is become thinner and the cathode become thicker. And the brown residue is from bottom the solution. But for the lower concentration, you can observe that in the second picture, there are the copper floating and also the copper sink on the bottom of the solution. This is due to the same current actually apply for the whole for the all concentration, but for the lower concentration, the same current used may be considered too high to them. So there are few ions to carry in the solution. So this caused them the plating become rough and also the uneven plating. From the graph, we can know the relationship between them. The mass is directly proportional to the concentration. The rate of deposition and cell efficiency also directly proportional to the concentration. While cell efficiency represents the amount of the electron can be used for copper ion to be reduced. And what is the special finding? For 1.00 m, the experimental mass is 0.2971 gram, which the experimental mass exceeds the maximum theoretical mass calculated from the Faraday law, which is 0.1482 gram. It is out of percentage error, and also the cell efficiency also out of the range. This is due to the deviation of the current applied. For the precautionary step, which is adjust the voltage based on the reading of current, use the trial cell to detect the real voltage need to use and start the timer once the electrode had immersed, since the reaction will happen after the electrode had been immersed, and use the hairdryer.
Last but not least, we can say that our objectives were achieved because we can see that higher the concentration of the solution, higher the mass of the copper deposited, with the linear correlation is r squared equal to 0.934. However, in 1 molar of the concentration, we can see there is a overdeposition. This is likely due to the current deviation. So in the future application of each experiment, we need to pay attention in the voltage adjustment and also consistent in current monitoring. I think that's all from us. Thank you for listening.